All right, 4-10, Algebra 2. Here we are on this January 11th. It is 1/11. Put it in your notes, 1/11. Make sure your name is on your notes. All right, we're finding zeros of polynomials. By itself, it sounds easy, but it's using the fundamental theorem of algebra, which is confusing. So before I begin talking about the fundamental theorem of algebra, let's talk about some vocab. Roots. Roots are wherever the polynomial is set equal to what number? Quiet raised hand. Roots. Polynomial is equal to what? Take a guess. Gio.
Wait, I don't even know how to say.
No, guess a number. Where the polynomial is set equal to 0.
Yay!
Stego, turn in your card.
That's not fair. You asked me not. That's good.
Where is my class graph page? There you are, Stego. 50, and let's see, Fiona, you're gone. Chris, you're gone. All right. So, which is the same as where it crosses, write this down, it crosses the what axis? Y equals 0 is where it crosses this. Quiet raised hand. Quiet raised hand. Andrea.
Good
The
job,
X
Freya.
axis.
You're so positive today, Stego. I love it. I love your positive.
I'm loving it too.
Always something positive.
All right, degree. When I say a polynomial has a degree 4, what am I really saying? Anyone want to try to make the definition for degree?
No. Actually, no.
Quiet raised hand with a card if you have it. Card.
I have Fiona's
No, you can't use Fiona's card. She's not here. Degree. This is the highest
The highest, that's good.
or largest power. So, for example, and I'm still talking about degree right now. I am skipping down here. The largest power of this polynomial right here is 3. Therefore, this is a degree 3 polynomial. Are we okay with that? That's how I use the word degree.
Yes.
All right, let's talk about the fundamental theorem of algebra. It is a short and simple statement, but it is a very complex idea, I guess. So every polynomial of degree n has n roots. That means if I have something with a third degree, it will cross the x-axis 3 times, right?
Sure. Wait, x-axis 3 times?
This x-axis 3 times. This is degree 3, so it crosses 1, 2, 3, right?
Wow.
It should cross 2 times. You're correct. So James, if I have a degree 7 polynomial, it'll cross the x-axis 7 times. There it is. Uh-oh. That's the easy part. Here's where it gets complex. Yeah, turn it in, James.
Wait, what?
Here's where it gets complex. Look at this polynomial. X squared plus 4. I graphed it for you. How many times does it cross the x-axis?
Once. 2 times.
Here's the x-axis. How many times does it cross? 0. What?
Because it's
Why is that the case? Here's the reason. Sometimes your roots will be complex. A complex root means that you do not cross the x-axis. It still satisfies the fundamental theorem of algebra, but it doesn't cross the x-axis. And here's the other cool part, and I starred this. Complex roots always come in pairs. So here's a possible number of complex roots. 2. Quiet raised hand. What's another possible number of complex roots? With a card. Gio.
1.
Nope. 1 is not an even number. Steflon.
Oh, never mind. They have to be even. 4.
Ah, 4 is an even number. Ah! What's another possible number of complex pairs? Or yes, Gio. 6, exactly.
Yes.
Turn them in, turn them in. Yes, it's that easy. Teflon, there you are. 2, 4, 6, etc. It needs to be an even number. So let's talk about possible combinations of roots. So if I have a degree 1 polynomial, then how many roots do I have? By the fundamental theorem of algebra, all the way up here, if I have degree n, how many roots do I have? 1. Yeah. If it's degree 1, it has 1 root. If I have degree 2, I have 2 roots. If I have degree 3, I have 3 roots. If I have degree 4, you have 4 roots. Exactly. We are talking about the fundamental theorem of algebra. That makes sense. But possible combinations, this is where it starts getting complex. If I have degree 1, I have 1 root, and that 1 root has to be real. Because I can't have a pair of 1. I have to have 2 of them. But if I have a degree 2 polynomial, I can have 2 real or 2 complex. Now it's a possible either-or situation. Let's try it for degree 3. Quiet raised hand. This is a hard concept, but I think you guys can get this. If I have degree 3, Knowing that complex roots comes in pairs of 2, what are my possibilities? There's 2 possibilities. You need to get both of them. Eva. 3 real, yep. Or, what's the second possibility? Yep, or 1 real and 2 complex. And 2 complex.
Good job, Evan.
Good job, Eva. That was hard, and you got it. Very nice. How many people still have their cards? Does everyone have their cards in? All right, everyone can go multiple times now. Here's degree 4. There are 3 possibilities. Ooh, let's see if we can get them. I'm going to do R for real and C for complex because otherwise I'm not going to be able to fit it in here. If you can get all 3 possibilities, raise your hand. Maybe. James, go for it.
4 real.
4 real, that's the first possibility.
2 reals.
2 complex or
4 complex.
4 complex. There it is. Yeah, very nice, James. Good job. That was hard and you got it.
Wait, I don't get how you get, I don't know how you get the 4 complex.
Because you can have 4 pairs of complex numbers. 4 complex roots.
Right? Because it's even?
Because even, exactly. And here's the cool part too. If I have a degree 7 term, I will always have one what? One root. What type of root? If I have a degree 7 term, no matter what, I will always have one real root. If I have a degree 9 polynomial, I will always have one real root. Because odd numbers don't let all of the roots be complex. Because complex numbers come in even pairs. Yeah. So I think everyone that's here is going to get 50. Everyone here gets 50 for working together on that last one. And then G, I'll give you your additional 50. All right. So let's talk about multiplicity. Multiplicity is this cool word. Let's find the roots of x squared minus 6x plus 9. Use your advanced ninja star in your head. This factors as what times what? Advanced ninja star this in your head. What times what?
3x.
X minus what?
Oh, 3.
X minus 3, x minus
3.
Yeah, Gio's on it. I'll give you, Andrea, the points as well. X minus 3, x minus 3. Hey, look! I have 2 roots. My roots are 3 and 3. Because you set this equal to 0, right? Roots are wherever you set it equal to 0, so it flips because you're setting it equal to 0. I have 2 roots. And they're both the same root. Whenever you have multiple of the same root, that means you have a multiplicity, in this case, of 2. So root 3, multiplicity 2. Sometimes you'll have a multiplicity of 4 because you have 4 of those roots. Maybe you'll have a multiplicity of 7 because I have 7 of these 3's. However many times this root comes up again and again, that's called its multiplicity. It's not super important for this lesson. It will be in the future. I'm kind of setting the groundwork for the future. This is not needed for the homework unless you want to talk about it with your friends. All right, irreducible quadratics. Ooh, I messed up the cue there. Quadratics. So we all remember the quadratic formula. Do we want to sing it as a class? X is equal to negative b. Okay, anyway, there's our quadratic formula. Look at this square root part. If the inside of the square root is negative, then I have a square root of a negative, which means I'll have what complex part? Eva? What will pop out of the square root? This was from yesterday's lesson. If I have square root of like negative 36, say it again louder, you'll get an I. You will be in the complex plane. Man, Gio's just killing it today. You have a question? Yeah.
Can I get the worksheet for 4-9?
Yeah.
Yeah, me too.
There they are.
Get the money.
So, if this inside of the square root is negative, all of a sudden, you can't solve it unless you're in complex land, right? Notice that all these questions on the back are what are the real roots? What are the real roots? So if I have a negative in here, that means I don't have a real root. I have an I that pops out, as Gio says. So this, by the way, there's a special name for this. And that is the, oh man, Mr. Sindel is blanking on the name. This is called, I think it's the, I'm so sorry. I don't know the name of this, but it's whenever this thing, b squared minus 4ac, whenever this thing is less than 0, because that means it's negative, whenever this thing is negative, That means the quadratic is irreducible whenever you're talking about real numbers. It makes it complex. It makes it so that you can't solve it if you're limited to real numbers. I'll come back to this in a sec, probably after the notes, because I totally forgot what this is called. All right, let's do an example.
Wait, can you go back?
Yeah.
Okay.
Whenever this thing underneath the square root is negative, then that's bad. You can't reduce it. All right. So what are the distinct real roots of this polynomial p? So the way that we solve these is factor them, just like we factored this one up here. We factor it, and then you find all of the different roots.
Okay.
So how do I factor this guy? Whenever I have 4 terms, and this is a review from like forever ago, whenever I have 4 terms, how do I factor this? Factor by grouping. Factor by grouping. I go like this.
Oh, yeah, that.
Whenever I have 4 terms, I factor like this.
Wait, this is the first
What can I factor out of the first pair? Andrea, go for it. X squared. And what's left, Andrea? 2x plus 5. 2x plus 5. Good job. Andrea, you getting your XP in there? Finally stealing some from Geo. And then what's the next thing that I can do? I'm going to add this other thing, but I'm going to factor something out. And make sure that this 2x plus 5 is right here. 2x plus 5. What factors out of it? Stego. 9. Careful. Eva, help her. Negative 9. Yeah. Menos 9. Minus 9. Perfect. So, Eva, I'm just going to give you the 50 XP. And Stego, sorry. That's an attempt. All right. So, from there, how does this factor? Who remembers the next and final step? Only 2 people know. I'm going to wait until I see 4 hands. Unless we forgot 3 hands. Where's one more hand? One more person, although we have a smaller class. Okay, Eva.
Okay, you're gonna do x squared minus 9 and 1 set of parentheses.
X squared minus 9. These things that were factored out in one set of parentheses, and
And then 2x plus 5.
2x plus 5. There it is. Good job, Eva.
Yeah,
All right, that's how it factors. Now I'm going to find the roots. I find the roots by...
Wait, it's plus 5?
Emma, you are so smart. How will I know?
Yeah.
She works hard. She does. I don't like the way people say that they're smart because, like, I think that everyone in here is smart. I just think that some people work harder than others. So let's, from now on, say, Eva, you have worked hard to get to that point where it looks like you're smart.
But you're such a hardworking person.
Oh, yeah, there it is. Such a hardworking person.
Nice, dude.
Oh my
Keep
God.
going.
Keep going.
All right, how do I find the roots?
Did you not get H?
But that's the
Or you can say that.
How do we find roots? We have factored this. After we factor, how do we find the roots? How do I find the roots? Roots are wherever the polynomial, so set it equal to 0. Set this thing equal to 0. Now we're finding the roots. Okay, do you guys remember this rule where if you have some numbers, I'm just going to say A and B, and they're set equal to 0, that means either A is equal to 0 or B is equal to 0. This is called the zero product property. In some cases, it might be both. We just assume that they're both because both of those could get you answers. So that means that x squared minus 9 is equal to 0 and 2x plus 5 is 0 because both of those will give you an answer. Both of those are roots. All right. Who's going to help us factor the left-hand side? X squared minus 9. How do I factor that? I can't call him Geo because he's getting too much XP. I need to spread out the love. X squared minus 9. Who wants to do this one? Stego?
Wait, I'm sorry if I'm wrong. Did you add 9 to both sides?
You could do that, yeah. You could either factor this or you could add 9 on both sides. There's 2 ways of solving this one. So if I do x squared is equal to 9, and then what do I do finally, Stego?
Divide by x squared.
You can't divide by x or x squared because what if x was 0? I square root both sides. When I square root both sides, I get x is equal to plus or minus what? 3. So there's 2 answers that popped out of there. Plus or minus. Whenever you square root both sides, you have to do plus or minus. Here's another way that you could have solved it. I'll solve it over here. If I factored this as x plus 3 times the conjugate pair of x minus 3, remember, difference of squares factors to this conjugate pair. That's the other way of solving it. And then you use zero product property again. So that's that side of the answers. What's this side of the answers? What do I do to both sides? Just shout them out.
-5.
Minus 5, so I get 2x minus 5 is equal to -5. Let me back up. Is equal to -5. And then finally, x is equal to, shout it out. -5/2. Those are all the roots. Let's list them just to make sure that we know all of them. One of them was -3. The other one was +3. The other one was -5/2. Those were all of the roots. Because it was plus or minus 3 over here, so that's where the 2 roots popped out of. What time do we get out of this class? We get out of this class at 12:10. We have 15 minutes left. This next one is going to be a lot harder. I'm sorry.
Why?
Because you have never practiced it. That's why it's hard. Yes. What's up? Yes. Homework is doing whatever I'm doing in these examples. It's the same thing. All right, example 2. What are the distinct real roots of p? This one is going to have complex roots, I promise. This one is going, well, maybe I don't promise. I haven't actually looked at this one. I'm pretty sure this one does not have all real roots. I'm pretty sure some of them are complex. All right, so we need to look back at our notes because what's happening here is I have 8 and 64. 8 and 64 are perfect cubes. This is a sum of cubes. We have never practiced the sum of cube formula, although it is in our notes. Flip back through your notes. See if you can find sum of cubes. What is the formula for sum of cubes? Whoever gets it first gets XP.
What?
Sum of cubes. What is the formula? And if you just know off the top of your head, that would be even cooler. In fact, Andrea's got it.
Sum of cubes?
Sum of cubes, yep. If I have a cubed plus b cubed, what does that equal to?
A plus B.
A plus b.
And then A squared minus AB plus B
Oh.
And since you're there, Andrea, can you give us the difference of cubes? Because this guy right here in example 3 is a difference of cubes. So if I have a cubed minus b cubed, what is that, Andrea?
A minus B. A squared plus AB plus B squared.
This is just way too confusing.
Yeah, I'm already failed.
It's just a formula that you're going to have to remember.
Oh.
On the quiz and test, I will let you have a note card with the sum and difference of cubes.
You go for it?
We did this.
We did it, but we didn't practice it on Khan Academy.
Wait, what lesson was that in?
Andrea, what lesson was that?
4-7.
4-7?
Okay, yeah. That's it.
It was at the bottom, I think,
Yeah.
bottom of the front side.
Yeah.
All right, so this is a difference of cubes. We haven't really practiced very much with it, so let's do it now. When I do this thing, I have a plus b. So I have to do, remember, I have a cubed. I have to do the cube root of whatever a is. What is the cube root of 8x cubed? 2. Yep, that's the first part. 2, and then I have to do the cube root of x cubed. 2x, yeah. Eva Gio, you got your XP. So 2x, and then I'm going to say I have to do this plus sign. So plus sign, and then what's the cube root of 64?
Ocho.
That's the square root of 64. 4. There it is.
Ah.
I think that was Stego and Eva.
And me.
Just everyone. Let's just give it to everyone.
Let's go.
So 2x plus 4 times the quantity of what? Use the formula.
2x squared.
Careful. That 2 is squared also. 4x squared. Because I had 2x, that was a. Because that was a. Now I need to square a. So I square 2x. That's 4x squared. So 4x squared. And now I need to multiply these two numbers. These are a and b. I need to multiply those two together. 8x. Oh, and it should be minus 8x. Minus 8x. And then
Plus.
16. There it is.
I'm confused.
Bird.
Because you're like,
Plus 16. Wait, what was the?
Plus 16 because I had to square this b term.
I don't know where he got this. That's
16, that's my question.
You squared the x q4.
Oh, right.
Square root of 4 is
Because then
64.
2 times 2 times 2.
Yeah, but like,
And then that's
doesn't supposed to the middle
that's
term be
64.
2
They
things?
went back.
Oh, because you multiply 2 and
That's
4, right?
Like you're following this
Ah.
point to get and you get 4
They
So
go
that's
there.
fine.
They're going to multiply your 2x by.
So far, so good.
Okay, I got it now.
All right. From here, I guess we could have done this at the very first step, and I'm realizing that now. But we can factor out something out of this one.
X.
2. 2 times x plus 2.
So confident. X.
Good guess, good guess. You're still getting XP by doing that.
I got it right.
You did get it right. What can I factor out of this one?
Quadro.
4. I can factor out of 4, and then what's left over?
Dos.
X.
Careful, careful.
X squared
Squared.
minus
Minus
2x.
Plus 4.
4. There
Yeah,
it is.
everyone got that one right.
Yeah, I said the
Yeah,
4. You just didn't hear me.
Yeah.
All right.
You're right, Joe.
This one can't be factored anymore. Can this one be factored anymore?
Yes.
What is it?
You factored 2.
If you do a ninja star with this one,
Yeah.
ninja star this one, it's going to be 4 and negative 2. What adds to negative 2 multiplies to 4? Or sorry, multiplies to 4 adds to negative 2.
2 negative 2 times negative 2.
And that adds to negative 4. And here's the key. I don't think it does factor because we can check if it's irreducible by checking this b squared minus 4ac. Let's check b squared minus 4ac. b squared minus 4ac. Let's check this. So what's b squared?
2x. Negative 2x. Negative 2x.
So b is the negative 2.
Negative 2.
So b squared is,
4.
so 4.
Oh my god.
I don't know what we had to.
So right now we're checking if it's irreducible by using this. We're checking this term to see if it's bigger or less than 0.
Oh, that's for that.
So I copied it down and I'm checking to see if this thing is bigger or less than 0. So I'm going to say minus 4, what's a?
Oh, X.
No, it's a
Nothing.
coefficient,
Nothing.
What?
Nothing.
so it's 1.
Dang.
And what's c?
4.
Cuatro.
C come from?
So that's 4 minus 16, which is negative 12. Is negative 12 positive or negative?
Negative.
Negative, it's irreducible.
What?
I guess.
It's irreducible because it's less than 0. This thing cannot be reduced at all.
Wait, don't erase that. We need to copy that down.
I'm going to keep it up on the notes. I just want to erase all this. We couldn't use Ninja Star, sadly. All right. That means if it's irreducible, this only has complex pairs. There were 2 pairs because it's degree 2. There are 2 roots, and both of them were complex, which means it's not a real root. We were looking for a real root. This one has complex roots. That's why there's no answers. So if I set this thing equal to 0, I'll get the complex pair. Don't worry about it. Set this thing equal to 0. What do I get? X plus 2, set that equal to 0. Therefore, x is,
2.
careful,
Negative 2. Oh my gosh.
You have 10.
Dude, I have a thing with not liking the negatives. No, wrong
That's me on Khan Academy.
side.
x equals negative 2. There's the real root. Box it.
So, okay. Gotcha.
All right.
Wait,
And
are the answers in carry multiple choice, or we have to do the work?
you have to do all the work.
So the negative 2 is the only answer?
Bruh.
Negative 2 is the only real root. There are complex roots, but I don't want you to find that right now. Neither does Khan Academy.
Oh, the other one was irreducible.
Yeah.
Okay.
It's irreducible in real land. If it was in complex land, then it is reducible. We're in real land for all of today. All right. So, example 3. What are the distinct real roots of this one? So again, reduce this using Andrea's formula. Andrea discovered it in the depths of the math world, the under realms, and then now we're going to factor it. So what is the cube root of this, cube root of this?
So the cube root for x is x.
X minus 3. So far, so good.
Oh my god.
Next,
X.
Careful.
X squared.
Ah, there it is.
Ooh.
James with the points. Gio with the attempt.
I'm still getting points.
You're still getting points. Yeah, keep going for it. Keep going for it. Next.
7x, 7x.
No.
Nope.
What do you mean?
Keep trying. I multiply these two numbers.
Negative 3x.
There it is.
Yeah.
Negative 3x. Gio's got it.
Wait.
That's what's up.
I multiplied these two numbers.
Oh, I think that's a cube.
Negative 9. 9.
But there's an error here. I don't know if you guys can see it. It's right here.
Is it
Positive
positive 3x?
Yeah, it's positive 3x.
Wait, do I get an attempt? Do I get an attempt?
I'm not gonna take it away.
Okay.
And then finally, do a plus sign because there's a plus sign right there.
9. 9. I said 2.
I'm just gonna give it all y'all.
Yeah.
All right. Let's check if this thing reduces or not. Yeah.
Yes.
All right. Let's check if it reduces. So again, I'm gonna copy down this b squared minus 4ac. B squared minus 4ac. Let's check this guy. Again, there's an invisible 1 in front of the x squared. So, b squared. What is b squared? 9. That's
Everyone can have it, you know.
No.
Yeah.
9 minus 4. What's a?
1.
Times c, which is
9.
9. So 4 times 9 is?
It is reducible.
Negative 36.
9 minus 36 is?
Actually, I don't even know.
Negative 27.
Negative 27. Negative or positive?
Negative.
Negative, therefore it's irreducible.
What was that, you?
Okay, I was wrong. But still got points.
This is irreducible. And here is the cool fact that needs to be in your summary. Whenever you do a difference of squares, this other garbage thing that has 3 terms is trash. It is trash. Because, well, for now it's trash. Whenever you do a difference of cubes, this term and this term will always be irreducible. Every time you do a difference of cubes. If you're in real land, it will always be irreducible.
Oh, so we didn't even have to do the math.
Well, you didn't knowing that trick, but now you know the trick. Don't worry about that thing. It will always be irreducible. Worry about this thing. But I also have this x plus 7 squared still. So don't forget your x plus 7 squared. But it's already factored. It's already factored.
Oh.
It already factored it for you. So I have this thing and this thing that have real roots. Set them equal to 0. X minus 3 is equal to 0. X plus 7 quantity squared. Set equal to 0. Gio, you got this one?
No, I got that.
X plus 3. Wait, x equals to 3. X equals to 3.
You're good. All right.
Wait, do I get an attempt and a correct answer?
No, I'll just give you the correct answer.
Woo.
All right. X plus 7 squared. Square root both sides.
I'm a hustler, right?
Square root both sides. Square root both sides. I get plus or minus 0, which is just 0, is equal to x plus 7. Therefore, x is...
Positive or negative 7?
Careful. No, I just have this one. Negative 7, exactly. Those are our answers. Our answers are 3 and negative 7. Box it.
I said we all get.
Yeah, I said we
Yeah, we all get that.
My ears are bleeding from
All right, that concludes the notes. In your summary, talk about how when you do a difference of cubes, that second term is always going to be irreducible. That needs to be in your notes
Wait,
for your summary.
So your answer is 3 and so, okay.
3 and negative 7.
So wait,
Everyone was positive and hardworking for the notes. Everyone got 100 XP.
Great.
Wait,
Everybody
it's
was
just another so
yelling
when
in my
you
ear.
the square root both sides, you get rid of the square root and just do the same thing. Okay.
Yeah.
And the answer is 3.
Cool. That concludes the notes. Write your summaries now.